In this video, I'm going to build a little mech MIDI musical model. And to do that, I need a bunch of interesting metallic conductive shapes. So these things here are upholstery pins or upholstery nails, and they come in lots of fun little designs and shapes and colors. So these are really good for some interesting touch sensors. This is a DC motor. This is a little broken DC motor, and if you take it apart, it's got a really cool looking component inside. They've got a proper name. I think it's armature. No, it's not an armature. I can't remember. But they look cool, and they work really nicely as touch sensors. So I'm going to grab a couple of those. For the actual hardware for this is all we need. We've got a Raspberry Pi Pico, which is that green thing, which is a microcontroller that can do lots of different things. In this particular model, we are just going to have it be like the brains for a bunch of touch sensors. So the whiteboard, the white PCB, lets you just tidy it up and keep it nice and neat. We're going to need one resistor per touch sensor. So I think I had 15 touch sensors on this board, so I need 15 resistors. So again, each one of those goes on the PCB, and then we solder those. And soldering is actually pretty easy. It's pretty it's safe once you know like which bit of the iron not to touch. Like the metal bit gets hot, don't touch that. And the rest of it is just about basically doing what I'm doing here, which is just tiny little bit of solder, and it's like a metallic glue that holds stuff together. So I'll do another video maybe on how to solder. Because it's not that hard. I'm going to chop all the little legs off so that they don't create a little short circuit, and that is all the electronics for the brains of this mech. So there we have it. After we've soldered, the next thing we do is we need to wire up some of our touch sensors. So get a little bit of wire and make sure you do this bit out of camera so that you can't see what's going on. Perfect, thank you. So you strip the ends of the wire so that you get rid of all the plastic coating, because that doesn't conduct electricity. And then you get these electrical blocks. This is terminal block or shock block or whatever you want to call it, and there are these little screws inside a plastic casing and a little sort of brass holder. So with the upholstery pins, this is really good because you can just put the nail part in and screw it tight, and then put the wire in the other side and then screw that tight, and then that's all you need. You don't need to solder these bits. That as it is would work perfectly as a touch sensor, so we can control software or play games or play music on this thing. So the other end of the wire goes into the brains, into the spoke. This board is a spoke mini, which is something I've invented, and you can look in the details on how to get your own. Solder that wire in place, and then that's done. So do the same with the other touch sensors, or I do the same with the other touch sensors. You could also solder some wire onto your parts. So for this one, I'm putting solder on the wire and on the component, and then joining them together. That's called tinning, I think it's called. And that's the easiest way to just solder straight onto a different object. It's a good thing to get stuff ready, so I've chopped up a bunch of the terminal blocks ready to connect. This wire, at this point I don't really know where stuff is going to go on my build, because I haven't built the build yet. It's always a good idea to solder straight onto plastic, because then you can leave these cool marks, and then you can hide them with your terminal blocks. And yeah, don't solder onto plastic. That was pretty stupid of me. Use these blue. This is blue things like it's called a helping hand. It's a little crocodile clip on some armature wire, and you should solder sort of in midair. This is a countersink used for making holes a bit more pointy so that you can hide drills in it. And I filed the top a little bit first before I tried to solder it. A lot of metal things have sort of coatings on the outside, which don't really solder very well. So if you file the top layers off, you get a better chance of actually getting solder on there. Solder itself isn't always that strong, so I'd like to put some hot glue on top of the solder to strengthen it a bit. So this will strengthen the connections and hopefully stop it from breaking. Hot glue itself is a conductor. No, it's an insulator, not a conductor. So you can't really join stuff together with hot glue because it won't be electrically connected. So I got all the sensors ready, and now I wanted to start building my robot. I know I wanted to build a little robot, but I didn't quite know what kind of robot it was going to be yet. So I got a bunch of packaging, some little boxes, some little containers, and I decided to start with just the most interesting shape. So this was a donut container. So this is packaging for holding donuts, and whoever designed the packaging for this donut container really went overboard. There's lots of little details which really I don't think are necessary for carrying donuts. But they look pretty cool. So I chose this packaging to be where I start the build process. So there's lots of little sort of grill looking things and some really cool shapes. And this part took a lot longer than in the video. This took loads of time because I was figuring out how things could fit together. So I got the boxes and just held them up to the plastic. I tried making a little template for the back of the plastic to see if that would work, and it didn't really work. So I ended up just holding the boxes up to see sort of roughly what shape it could be. And also I needed to remember I had to include the electronics. So it's a good idea to also just hold up the electronics to the build to see where stuff will fit. I only used hot glue in this project. You can use super glue and you can use PVA glue, and that's perfectly fine to do, but I wanted this to be fairly quick and easy and accessible. So I don't really use super glue when I teach, just because it's not good for kids and it's smelly, and if you get hot glue on your fingers, it's just easier to cut your finger off and wait for it to grow back. All of this was done with hot glue, and I literally just lined up the boxes with what kind of looked good and then glued on and went from there. I didn't plan it this way, but actually gluing the boxes that way around made my life a lot easier later on, and you'll see why later on. These plastic bits were from when I ordered the Raspberry Pi Picos, I ordered quite a few of them for a project, and they came in these little plastic containers. So I'm using the Picos, but also I'm using the packaging for the Picos. It's always good to use all parts of the animal, so this is that. I wasn't quite sure what they were going to be yet. I know they were a pretty cool shape. So again, with this, I played around with the position. I thought maybe on the chest, maybe it could be some kind of hat or a backpack. And then I slot it in that gap, and it fit perfectly with the shape of the donut packaging. Like, it just slotted nicely. So I needed to figure out sort of what position I wanted him on in. So working out the angle of the arms was moderately important, but I decided in the end it doesn't matter. I'll just glue it on and then I'll come up with a narrative for it later on. The legs were just bits of cardboard. Nothing exciting, but they fit nicely in this little nook in the donut packaging. So, okay, perfect. These, I could have gone really complex with the legs and done all sorts of weird things, but I decided not to. Keep it simple. It's always good to keep it simple, and I can add details later on. So just some cardboard legs to be the main structure, and then I'll work out later on what those legs are actually going to look like. So here we have the main body of our robot. Now's a good time to start adding some of our sensors. So I'm going to use some super duper sharp pointy tweezers, and then the wire is going to just be threaded through the body and out the other side. So this metal rod is going to be like a little antenna that sits on near its head, on its back. And I always find this robot is going to be sort of touched and manhandled, and if it's going to be super fragile when I build it, then it's not really going to work as a controller either. So I'm not delicate when I do this, because I'm probably not going to be delicate when I use it either. So if it breaks now, I can at least find all the weak spots now. Oh, this is so I said earlier I put the boxes this way kind of by accident, but it made my life so much easier because I could open up the boxes to do the electronics. So I've got two little embroidery pins on its head, which I'm going to thread the wires through and come out the bottom, because the spoke, the wiring is all going to be at the sort of the butt end of our robot. So I need to wire up all the wires so that they go in that general direction. So there we have our wire being threaded through, and I can even open this box to get to the inside as well, which was definitely planned, definitely me thinking ahead. Yeah, I need to remember that for any future builds, but that's actually a really useful way to do things. Good job, me. So I'm talking as if you're going to be building this. You can build this. This is fine. But once I have done that, I finish tightening up the connector blocks and then doing the other ones. So again, poke some holes, feed the wires through, and they don't have to be super duper hidden. Robots and mechs and things have got wires on the outside, and it can just be part of the design. It can be part of the aesthetic of the model. So I'm going to close its face and figure out where some of the other sensors are going to go. And it's starting to take shape. I quite like how it looks at this point. I can see the potential. So the motor part is going to go there. A little bit of hot glue to hold it in place. And that's done. There's this spokey gear type thing which I found, and I put that on the back, sticking up. I think that would be a nice little embellishment. What do I do next? Yeah, so with the countersink, it looked a bit messy, so I chopped up this pen lid so that it could fit inside the pen lid, and I made sure I did it just off camera so you can't really see what I'm doing. All of my sort of modeling, making, building skills and techniques I learnt from other YouTubers. There's the incredible Studson Studios. Bill Make Stuff is amazing. There's a guy called Trent, who his label is Miscast, who does miniatures, and I get inspired by them. They were the first ones who made me want to start making things because it's actually really fun and making miniatures. I've been making stuff for decades, mostly musical instruments, mostly interactive installations, but making little models like this. I learnt it from them. I needed at this point I was counting how many I actually need. I forgot how many sensors I was adding. I forgot to talk about this bit. Actually, no. So here, I'm doing the electronics now, and I'm not going to cut or edit this part because I want to show in real time how to get it sorted. So I use CircuitPython, which is a type of code that Adafruit have running. And when you buy a Raspberry Pico, it comes empty. There's nothing on there, so you need to set the environment to be a certain type of code. So I'm going to use CircuitPython. So I just downloaded it from their website, and now I'm holding down the button and plugging in the Pico, and then what I downloaded was something called a UF2 file, and I drag that over to where the Raspberry Pi turned up, and then that turns the Pico into a CircuitPython device. While it's doing that, I'm also going to download a couple of libraries. And libraries are, if you're doing specific things on a Pico, you might need specific libraries to do that. And because we're using MIDI, I'm going to get the MIDI library. And I literally just drag a folder from there into my Pico. And I might want to play games on it later, so I'm also going to grab the HID library. So that's it. Now the Pico is set up. To test my code, I'm going to use some MIDI code. So this is some of my example code, and if you open up your code in Notepad, and then you can just copy and paste some of the example code, and then click Save. That code is now on the Pico and ready to go. So if I now I'm opening up .piano, which is a MIDI website that you can play MIDI controllers on. So that website is now open, and I've got it all set up. Enough I just start touching parts of the robot, it will play some piano notes. So there is some piano. And that's how easy it is. I actually did it so fast I struggled to keep up on explaining. So all of the wires that are there, they are also already ready to go. They don't have the sensors on them yet, but they are working as touch sensors. So now I know the code works, and the touch sensing is working, and we have a half-built MIDI controller. And that was all just in real time, so that you could see how quick it is to get this stuff going. Now that it is working and I'm happy with it, I can close it up a bit. I can add a belly to hide some of the electronics, and I can start working on getting the cables sort of nested and a little bit neater, and then I will figure out what the cables are going to do later. So they will be other touch points, other conductive sensors, but at this point I don't know where they're going to be or what they're going to be. The feet were quite fun. This is packaging from, I think it was like a coffee holder maybe, but it's like recycled cardboard, pulped and shaped stuff, and it fit really nicely with the legs. So I thought they would be really good little feet. So one over there and one over there. And the robot he's taking shape quite nicely. I've added little bits and pieces, little embellishments, sort of curved wheels, and yeah. He's taking shape. He's looking good. I like it. I wanted a copper sort of sensor, so that's a tiny piece of copper pipe, and I wanted it on the front somewhere, so I thought maybe I'd do it there. So with copper, you can solder it. So I put some solder on the copper and then some solder on the wire and then joined them together and then added some hot glue to protect the joint. And then we have another sensor. So that is going to go on the belly. Right there. There. And then that's like part of a covered handle, like the metal base that goes behind the handle, which looked good on the shoulder. This is something, I don't know what this is, but it looked cool, so I used it. And that's going to go on that hand over there. So, yeah, taking shape. I'm pretty happy with how this worked out. Our robot needs to be standing up, and I got this little base. And the difference between it being at this angle and with his feet flat was actually quite dramatic. It looked like it was going to fall over if its foot was flat, so I needed it to be standing on something. So this is some polystyrene from packaging, and if you rip it up with your hands instead of cutting it, you get these sort of lumpy, bumpy bits which work quite nicely as rocks. So I decided he should probably be like standing on some rocks, just so that it doesn't look like he's going to be face planting and falling straight forwards. So glued that down. Plenty of hot glue because these are holding the whole model up at the moment. So that's the pose he's going to be in now forever and ever. Glued the wires down, and like I said, the mechs and robots and things have got wires on the outside, so these can be part of the aesthetic. They're functional, they're connecting all our touch sensors to our hardware, but they can also be part of the decoration. This stuff is like cross-stitching plastic, which make excellent windows. That's a little tip I learned from Studson Studios. They also make pretty good little ladders if you want to make tiny ladders. This is from packaging for button batteries. So if you order lots and lots of button batteries, they come in packaging like this. These are cool. They're quite fun little shapes. That was part of that same packaging. I wanted it to have a little hat, I guess. Yeah, at this point, I'm just adding lots of little details here and there just to give it more texture and variety. I don't have to explain what everything does because it doesn't matter. So there is our guy just about done with the aesthetics. I could add more details, and I am going to add more details. So these are coffee stirrers, which are little wooden planks, but they don't look quite wooden enough, so it's good to get some more texture on them. And these are going to go on the arm. And this mech, I should say, is part of a world I'm building with my friend Nick Murray. It's part of a series called The Beating Birch. And it's a story, and we're doing like world building, like fantasy things. We've written a bunch of music that came from this world, and we're going to work on some games that come from this world. And in this world, it's all about nature and how we can live better with nature. I'll talk about it a bit more. I covered it all in a mixture of paint and Mod Podge, which is a classic technique to tie it together a bit and also give all the surfaces the same texture so that you can paint on it evenly. Painting on plastic is kind of tricky, but Mod Podge sort of puts a layer on top of the plastic so you can actually paint it. And I'm not the best painter in the world, so I'm just going to speed this up. If you want painting tips, I would go somewhere else. I would go watch Bill making stuff, or Dan does things? Dan does stuff. Or Studson. Studson has great painting tips. Or North of the Border, he's another one. He does really good painting things. So yeah, like in this world for Beating Birch, it's all about the civilization that works, and in a giant birch tree. So this giant birch tree creates music, and the people in the society they mimic that music and they sing back to the Beating Birch, and that's how they sort of commune with nature. And so this mech is part of that world, and so I'm adding some flocking to this. So flocking is basically fake grass. So I've been painting it with PVA glue, which is a white glue, and this is flocking. I'm very low on flocking at the moment. And how you do this is you put paint on it, and then you sprinkle the grass on top, like this. And then the grass sticks to the glue, and then you have fake grass. I did quite a lot of painting off camera just because I forgot to record, but that's fine. So I wanted like some of the mech was going to be like actual like fields of grass on the robot, because in this world nature and technology work together. So having grass on the robot makes sense in this particular story. I'm going to slap loads of glue on the base, and then sprinkle loads of grass on top. I also I made a little house, 3D printed a little house on there to give it a sense of scale, because at the moment you can't tell that this mech is actually ginormous. So you sprinkle the paint, the grass on the glue, and then you rain microplastics down back into your tray, and then when it dries you've got a nice coating of grass. Ta-da! So now you're done with the grass, and no, I'm done with grass, so I can take that away. And I did a little bit more painting, a little bit more details, and this is the final result of the mech. I think it turned out quite nicely.